I'm very happy to introduce our last team talk for today. Team Ops is open for now. Please join us on the stage.
Yes, team operations on SCS. What are we on about? Team operations, operations as CSPs especially, you might know what operations is. It's the daily business of running platforms. And as the team for operations, we are looking closely at all the tooling, all the procedures, and all the best practices of running SCS environments and instances, which is in regard to operations, especially the build of software and the distribution of it, the setup and the configuration, the maintenance and the monitoring, and day 3 workflows, which are always kind of in the backlog because you only focus in the beginning, you only focus on day 1 because you want to deploy and get it running. And then day 2 and day 3 comes and you have to face different and more challenging stuff. And we have this on the roadmap, but as you all know, day 1 can also be very time consuming. And yes, as a special point in our team, we also had the ease of accessibility of the clusters by customers in scope. So not only CSPs, but also the end users, which is normally the end customer of the CSPs. They also had a place in our discussions. To get a bit from the abstract to the more being done part, the projects we want to present today are the Health Monitor from VP12, the central API, the status page and its API, and the project around Zuul, which is our CI/CD pipeline tool, and all the improvements and additions we made in this part. Right, so the SCS Health Monitor. Martin already picked up the work from VP12 in his talk earlier. Thank you for that, Martin. The thing is, many of you might know the OpenStack Health Monitor that is running in our community now, which monitors all the OpenStack instances, does some testing, gives out metrics, and can show if there are any issues in the platform. And the limitations were basically, we wanted to extend the functionality of this tool or of this concept in the technology of other platforms, like Kubernetes, like other applications, Keycloak, for example. And this whole concept is called behavior-driven testing. There are many different other phrases, I know, but it's the basic idea. So we had an idea. We wanted to follow up a concept in the extension of the platform, in extension of SCS, but the technology that was there was difficult to extend. So we thought about how to solve this problem. And so new concepts were evaluated, and we basically came from the OpenStack Health Monitor to the SCS Health Monitor, and it's built on an entirely new framework, which is based on Python, and it uses the Gherkin language and the Behave Python framework. Maybe some of you have heard of Gherkin. It's I would show an example. It comes from the Java world, but it's not Java. It's Python in this case, so no worries there. And the biggest benefit in this case is that at the current state, we cover both IaaS and CaaS, and we have all the possibilities to extend the framework towards other applications. Everything that talks HTTPS or something can be included in the behavior tests. So, and I want to show you some screenshots so that it's maybe more graspable what we did. This is the Gherkin language. It's basically a file where I write, I connect to OpenStack. I should be able to create how many ever I want networks. And then I should be able to list the networks. And in this case, I give it 2. And what it does in the background in Python is map this sentence I wrote in the test case to Python code, which in this case uses the OpenStack client to do stuff. And the result is then when I execute this test, when I run this test, here I run this test, I see it builds networks and it deletes networks. Those were 2 test cases. And in the end, it says the framework gives me the result: 5 steps passed, 0 failed, and it took 5 seconds. So what I know is that the IaaS platform that I tested with this test allows me to log in from outside, allows me to create 2 networks, allows me to view the networks, and allows me to delete the networks. So I have assurance that the APIs work and that the overall workflow of the tool, of the platform, also works. And as an example for cars, which is pretty freshly implemented, this is a test case we wrote to create pods in Kubernetes. And what it does is it creates 2 pods, pings between the pods, and deletes the pods, and it passed through. This might look simple, but what we know now is there's a Kubernetes cluster that lets me log in from outside to the API. It allows me to create pods, 2 pods, that have network between each other. They can see each other, and then I can delete the pods. And so I can be sure that my Kubernetes cluster is working as intended. And in the end, the team from VP12 also added metrics export to Grafana. So very similar to the OpenStack Health Monitor instances. We will in the end have a lot of dashboards and metrics and alerts, and they're all in Grafana, exported from Prometheus. And if you need it, you can also add alerting there. Then I hand over to Oliver for the central API.
Yeah, thank you, Dominic. I'm honored to present our work from Gunicus. One of them is the central API. And for our approach to things is we have developers in mind, the end customers of a cloud. And therefore, we say for developer teams, the user experience is really the key. And currently, if someone is using a cloud, there are several components that needs to be managed, like identity management that we heard about, OpenStack resources like VMs, networks, etc., or Kubernetes clusters. And currently, for the IDP, for example, we use Keycloak, so we need to use the Keycloak API. For OpenStack, we need to use the OpenStack API, obviously, and for the cars implementation, we use a Kubernetes API. And all those APIs have different approaches to what a resource is, how it is defined, how authorization looks like, how authentication looks like. And what we try to achieve is having one service in front of it all to unifies all that and gives a user the possibility to maintain everything through a single API, and hopefully makes it more easable for them to manage their infrastructure. And we chose an approach to use also a Kubernetes API because the main benefits of using Kubernetes is the authentication authorization is really well known and is already used by many people with the Kubernetes RBAC. Kubernetes has a really well-known way of describing resources with the Kubernetes API, and also we can quite easily achieve multi-tenancy support with using, in this case, cross-plane namespaces. And to build this central API, as I already said, we leverage crossplane, which is originally a tool for platform engineering. And we use it to providing a uniform SCS API so we can use it to describe OpenStack resources natively in Kubernetes resources, and also Kubernetes resources, obviously, to manage cluster API or even Gardener clusters. And we can also use other cross-plane providers to extend it even further. Yeah, and that's basically for the central API right now. Those capabilities are already working and can be tested. Then for the second topic of ours is the status page. And I think I don't need to explain what a status page is. Everyone has seen one before, I think. But we decided to do our own implementation. Why is that? There are really lots of status pages out there. But we did some evaluation, and we discovered a lot of them are not very well maintained. Some use quite old technology, and we wanted some approach that fits it even better. And we decided, how can a modern status page look like? And we decided on an API-first approach by defining an open API spec for this, how communication between the front end of the status page and a back end that holds all the data looks like. And we decided on the modular design, having an API server and a front end. And we delivered a reference implementation of this open API spec. And this really is only a reference implementation. You have the open API spec, and if you have some other needs, you can decide, well, I write an own API server for our status page, or the front end is not really that what we like or can use. We can also write an own implementation of that. And also our status page is deployable on any Kubernetes server. And good news for R7 of SCS. We are happily to announce that the status page is available and can be tested. Every information on that is in the R7 release notes. And with that, I want to show you some screenshots, which is already available on the SCS status page. This is how the SCS status page looks like at the moment. Maybe you are able to see it. We have some accessibility features as well, like some checkmark for colorblind mode, which changes the overall color scheme a bit. And we're also able to use a table display view. It's better accessible for certain people. Then, we also have a log of incidents, of course, as probably every status page has. And what's new in the current release is that we can also log in to the status page to set and manage incidents. In our current implementation, access is granted through GitHub. And when we log in, we can see, that's really me, and we can manage incidents. And there's also UI for this. We don't need any fancy curl commands anymore. And we can create new incidents. We can manage them. So the first real release is now finished, and now we can improve it even further. And then we can head over to the last topic, which will be Zuul.
Thank you. Level of coffee consumption and a little bit of noise there in the kitchen area tells me that people are having already difficulties with keeping focus. So please keep just a little bit, but I will try to be really very quick. So we are using Zuul. Why we are using Zuul? Well, because it has some unique features that we are relying on. It allows you to place your code pretty much on any Git hoster, and you can even combine all of them simultaneously, and you just define how your CI/CD system works in a central place. Test resources can be, so you can test either using VMs or you can use also Kubernetes pods for testing of your resources, projects, whatsoever. It supports multi-tenancy, full control of testing infrastructure, which is basically related to the last thing, which tells 100% sovereignty, where everything is in our hands, and we fully control what is going on there, because it's pretty much at the moment not a single any other alternative CI/CD system is offering that. So before I tell why and what we did, I will quickly explain some basics of the Zuul. It consists of few components. Well, this is just a list, and this is a diagram how they communicate with each other. This is more or less, it's not for you to really, in reality, to understand what is going on there. It's just to underline the complexity of the system. So CI/CD seems something easy, but in reality, when you go into the bottom and try to operate it, it's not. Tip. Okay. Nah, good. Reasonable setup. So basically one of the central components, as was shown above in the previous, here it is, Zookeeper, which is used to as a distributed configuration system to basically unify communication between all of the components. Therefore, this component is hugely intolerant for outages, let's say it like that. So in the reasonable setup, we need to have a really high available Zookeeper with minimum 3 instances, because this is also a component which requires quorum. We need database, we need some minimum 1 instances of those components. Zuul Web as the service, which is also offering API, is also at least 1 instance, but it should be also really high available as well. If you are not able to reach your CI/CD system, you are sad. And then there are 2 ways how to deploy, how to have Zuul running based on VMs. This is the way how at least some of the operators, currently big operators, are using it and deploying it. What have I wrote? No natural scaling capabilities. Yeah, this is one of the things. Basically, when I joined the project, Zuul was installed on a single node with pretty much no high availability at all, with some other limitations. But in my eyes, one of the most important things here is that it's much more expensive in the term of costs and operations to run such a complex system in this manner. This is maybe also one of the reasons why people prefer to run OpenStack on Kubernetes as well. And now let's have a look on Kubernetes setup. Basically, we can offer high availability using pod anti-affinity rules, placing all of the components on independent nodes in the best way, also in the different availability zones. We have really very easy possibility for scaling up, scaling down, whatever you want. We are having much easier day 2 operations of Zuul itself, like using any other existing CD system that deploys our tools into Kubernetes, and in that particular case, it's Argo CD, can be whatever you want. And generally, one of the most important things why we are going this way because it allows much improved secret handling capabilities. I'll show you right now about that. In Zuul, all the secrets are stored and managed in the declarative manner. They are basically just part of your Git repository, where your secrets are kept there in an encrypted way. That means that if you want to rotate your password, you need to create pull request, merge request, whatever, how it is called. But you can't literally just simply rotate password and create pull request, because that means that all of the jobs that will start at this period of time would basically fail. They wouldn't be able to access your target systems. So this is where the Vault, previously known as HashiCorp Vault, and you can use OpenBAO, and this is also how we do it right now, is coming into the game. Few words. This is a central secret management tool. All secrets are stored in single place. You have possibility to manage access rules for secrets, saying like this person is able to access, to read that secret, that person is available only to update that secret, and so on and so on, all the crazy things about that. You are able to audit all of the accesses to Zuul, or to secrets. You are able also to do quite easy automatic secret rotation and also dynamic, or so to say, one-time secret. So basically, in our case, the job starts, job gets a new secret, one-time secret, granted to access target system. It runs, job finishes, immediately secret revoked, that's it. Even if the secret is being accidentally exposed in the logs, nothing will happen. Well, it's still not good, but nothing critical happens. Open source. I don't know why. OpenBAO is open source, therefore maybe it's written there. And one of the most important things here, it enables a new, I wouldn't say actually honestly new anymore, a concept which is called secret zero. Every time you are provisioning a system, you need to feed some secrets into the system. For example, like your system needs to have access to database. Therefore, when you deploy your system, you also, in certain config files, you would be configuring password to this database. With Vault, this is not the case anymore. Why? And this is a diagram. A funny diagram, friendly stolen from HashiCorp website, which describes how typically your job can get access, your CI/CD system can get access to the Vault to get secrets. So basically also here, the job starts, as I said, job, because of running under the Zuul, Zuul is going to Vault, Zuul is requesting a secret, maybe one-time secret or maybe token, it depends on how you configure it in detail. It provides this secret to the job itself, and then job is capable of accessing, or either it is having a secret directly, or it is capable to access Vault and read all of the secrets that the job is allowed. So basically with this type of deployment, we don't need to keep secrets in Git repositories anymore. And also, when we deploy Zuul, we don't need to deal with any kind of secret. We don't need to have even database passwords or how to access GitHub whatsoever. So it's literally, you are deploying system, there are zero secrets, all the secrets are in a central place, and Zuul gets access to Vault because of different feature, because of infrastructure-based authorization or authentication, where because Zuul is running in a certain Kubernetes cluster that is granted access to the Vault, job is able to get all the data which is necessary, and that's it. Do you want to say something? Yeah. Where?
Yeah. Wrap up. Thanks. Yeah, thanks, Oliver and Artem. And yes, I want to wrap up operations. Thank you. And just make another advertisement for a new blog post around Central API. And the Health Monitor one is currently in revision, but it will be published the next days. So keep posted. Yeah, thank you.